first thing we're going to do with these three-dimensional shapes is find their surface area. The surface area is the amount of area required to make the shape. So if I take the area of all the different sides of the shape and add it up, that is the surface area, the area of the entire surface of the three-dimensional shape. The main thing that we're going to use to find these surface areas is what's called a net. A net is a two-dimensional representation of all the faces of a polyhedron. Because when we look at these, you'll kind of recognize them. Back in elementary school, there's probably a time when you used a net to build up a cube or a tetrahedron or a dodecahedron. Most likely a cube. You make a cube out of paper. You're using a net to do that. The net is useful because it lays out all the shapes that are required to make the three-dimensional shape, and we can find the area of each face and add all those areas up together. So if I have a cube and I want to draw the net of the cube, I know the cube has a top. Okay, and that top is going to go connect to the side. So if this is the top, I know it connects to this side, and then the bottom. And then it goes to the other side also. Okay, so that would be like this ring forming. And then I also need these two sides over here. So I could put those here and here. I could put the other one here. It doesn't matter where you put the other one, but so this is a net of a cube. Alright, I'll show you a little bit better picture of it. Right there. Okay. So we could number the sides here. If one's the top, we got 5 over there, 2 over here, 3 here, 4 in the back, and 6 on the bottom. This is a tetrahedron. It's a 4-sided shape. It's made of all triangles. So I've got a triangular bottom and 3 triangular sides. This would be the net. Let's get rid of this. This would be the net for that shape. So take a second and draw that one out. And the final one is a dodecahedron. So if you remember, a dodecagon had 12 sides. A dodecahedron has 12 faces. And each face is a pentagon. This is one of the Platonic solids. Platonic solid is a three-dimensional polyhedron that's made up of all the exact same regular polygon. So a cube is a Platonic solid because it's made up of all identical squares. Okay, this one is also a Platonic solid because it's made up of identical triangles. It's only triangles and they're all the same. And the dodecahedron is made up of the exact same pentagons all connected together, and this would be the net for that. So if I want to find the surface area of this, I would just need to find the area of one of these pentagons and then multiply it by 12. Okay, so that stuff that we did last chapter, finding the area of polygons, is going to come in handy when we start going to find surface area. So I want you guys to take a minute and try to draw the net for the rhombocube octahedron. Okay, so if you look at it, it's squares going around. Okay, squares going around this way. And then we've got triangles that fill in the little gaps. So rhombocube, cube because it's made of, it's kind of like a blown out cube. Octahedron, oct. So that means it's got 8 sides. So it's got 1, 2, 3, 4, 5, 6, 7, 8. If you take the ring around, there's 8 squares on the ring. So you could start with that. So I've got 8 squares going this way. 1, 2, 3, 4, 5, 6, 7, 8. And we have 8 going the other way. But this one will count for 1, 2, 3, 4, 5, 6, 7, 8. Okay, so if I wrap this around and wrap this around the other way, actually I think, let's see, this one goes around 1, 2, 3, 4. The 5th one here is actually going to be connected to that one, so my picture's not very good. So we'll still start with our 8 this way. And then let's pick one. Let's have this one be this right here. 1, 1. When I go up 1, 2, 3 on the 4th one, I'm also going to be 1, 2, 3, 4 away on this way. So if I go 1, 2, 1, 2, 3, 4. When I get over to here, this will be the exact opposite side, and this is also going to be have to be connected to the other one. So when I can go up 3, 1, 2, 3, but then I gotta stop because then I'll hit this one, and this one will go, 3 the other way. So I can go 3 this way, 2, 3. Okay, and then I need triangles in between. So this will get wrapped, this will get wrapped. If you notice, every square should only be paired with let's see, every other one. Every other one is only paired with squares, so that means I need triangles on every other one. Something like that. Let's check and see how good I did. Okay, the main thing is you need to be able to count how many squares you have on here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 squares. And then I'm going to have 1, 2, 3, 4, 5, 6, 7, 8 triangles. Okay, because that's what's important for finding surface area. Here's another way to do the net. Notice every other one has triangles connected, and instead of going all the way up here, they added squares onto these sides like that. So if we want to find the surface area, if the side of each square is 5 centimeters, well, that means the area of each square equals 25, and I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 squares. So I'm going to times that by 18. The area of each triangle, since this is 5, okay, and these are regular triangles. This would be 60 degrees. I need to find my height. So I'm going to do the tangent of 60 equals my height over 2.5. If I type down my calculator, I get 4.33. So my height is 4.33. So my area of my triangle is 1/2 my base times my height. So I get area of 10.83, and I have 2, 4, 6, 8 triangles. 86.6. Add that to my 25 times 18, which is 450. So add 450 to this. We get 536.6 square centimeters, or centimeters squared. That would be my surface area. You just find the area of each piece and add them all together.